of a class which creates an object. This object will go on the stack. That's it. Right? Very simple. Anything that you start with a new, it goes on the heap. Okay? What about stack? What goes onto the stack? We have the local variables. All the local variables go onto the stack. Right? All the method arguments, the parameters that you pass in, go onto the stack. Now, heap and stack are general concepts. It's not specific to Java. Any language, programming language that I know, any programming environment that I know, support stack and support heap. Okay? But in the case of Java, which is an OOP language, for stack, they have something extra. They have something called the this reference. Right? So the this reference will go onto the stack. Now, when you take 2106, right, you will learn that there are other stuff that we put onto the stack. But we don't worry about them in 2030, so you don't know. Right? So for 2030, you just care about local variables, the parameters to the function, and the this reference. Okay? And anything that you knew, all the objects, the new circle, new customer, anything that you knew, it will go onto the heap. Now, this includes things that you don't explicitly knew. Okay? So when I said new, it's either explicit or implicit, right? Sometimes you have things that you don't explicitly knew. For example, lambda. All your lambda's expressions, remember lambda expressions is just object, right? Anonymous class with new instance of that goes onto the heap as well. Right? So all the objects, either you explicitly knew or implicitly knew, goes onto the heap. Right? So your heap, your stack. What about metaspace? Now metaspace is a uniquely Java concept. Right? Other languages might have it, they might not have it, they have it, they might call it a different name. Earlier version of Java calls it a different name. And so this is something very specific to Java. Right? And for metaspace, what Java stores are things that does not belong to the heap nor the stack. Anything that doesn't belong to the heap nor the stack comes to the metaspace. In particular, if your global variable, right? Or in other words, your static variable. Remember, all the static variables are actually local variables. Are really local global variables. It's just that in Java, all the variable has to be part of the class, right? So it's sticking inside the class. And then when you access the global variable, you say class name dot something. Right? So this doesn't belong to object, so it doesn't come to the heap. It is not the local variable, it's not the parameter, it doesn't come under stack, so it comes under metaspace.
To find out the price of this.
How do you know when you declare a class, whether it goes to the memory, whether the static variables inside is stored, even though it is not created? Okay. With regard to memory set, how do you know when you declare a class, whether it goes to the memory? Okay. Now, when you declare a class, what what happened when you declare a class? Let's say I say customer C. Does it go onto stack or heap or metaspace? When you say customer C, what happened? Are you newing something? No, right? You're not, there's no new here, you are just declaring a variable. Okay. So it has nothing to do with it. Now when you say customer C, now where is this thing? Now suppose this thing is inside class server. You say class server, you say customer C. What type of variable is C? Is C a local variable? No, it's not a local variable. Is C a parameters? No, it's not a parameter. Right? So it doesn't go onto the stack. Where does it go to? Does it go to, we said nothing in the heap, nothing in the stack, it goes to metaspace, right? Does it go into metaspace? No. Why? Because it's not static. It's not even in the memory. Because you are just declaring a variable. You are just declaring a variable. You are just saying, oh, I have something called C here, the type is customer. Nothing happens. Okay? You are just declaring, nothing happens. You are not running any code. Right? Remember, you put things into memory, you create stacks, you allocate in the heap when you run your code. Right? With the exception of static variable. Static variable is global, it's always there. So whether you run it or not, it's always there in the metaspace. But when you say class server, customer C, you're not running any code. So nothing gets created. What if you say, no, I have a method, you have a method say simulate something, okay? And then inside this simulate class, you have a customer C. Does C goes anywhere? Does C goes on the stack? Does it goes on the heap? Does it go on the metaspace? No, it doesn't go anywhere because again you are just saying I have this function, inside this function I have this thing. You are not running the function, so nothing gets created. Okay? Is everybody clear on this one? Now, only when you say, only inside your code somewhere, when you run your code, you say simulate. Now, after you run your code, say simulate, at this point in time, not after. When you run simulate, you call simulate, right? So now simulate, you create a stack frame for it, right? So now, when you create a stack frame for simulate, C is a local variable. So C will go onto the stack. Right? Now when you do, if you have a server customer and then somewhere you say server S equals to new server, you say server S equals to new server, okay, S goes onto the heap because you are doing something. So S goes onto the heap, and since C is part of server, C goes onto the heap. Okay? So once you understand what goes on the heap, what goes onto the stack, you just trace through your code. As you call the function, you put something on the stack. Right? It's very mechanical. There's nothing difficult about it. Just mechanically, every time you call a function, you put something on the stack. Put local variables, these pointer, parameters go onto the stack, and then just write down their value, write down their reference. Okay? When you have new something, you put something onto the heap. So that's how you draw. That's how you draw your heap stack and meta space. So in the context of the question, right, which says that, how do you know when you declare a class whether it goes into memory or not? No. When you declare a class, the class doesn't go to the memory, right? Declaring the class doesn't cause it to be inside the memory. Only when you knew the class, you are allocating memory for it. And whether static variables inside is stored, even though it is not created. So as I said, static variables is special. Static variable is inside the meta space. All the static variables inside the class goes into the meta space because they are like global variables. Okay. So this is about heap, memory, and stack. Let's see. No more question from your book. You can upvote previous questions as well. Let's see, this is still 10 vote. If you want me to answer previous question, even though it's low vote, you can cut and paste again. Ask again, then I will answer. No question? Covariance, contivariance, invariance. What do they mean by Java generic invariant?
I'll make it
Okay.
for me.
Let me start with subtype. Right? So we said that we have a type S. S can be a subtype of T. Right? If anywhere that the code is written using T, I can substitute it with S. Okay? So for example, let's say that you have your object, maybe not object, okay, let's say you have server, right? You have your server class, right? And then you have your subclass, let's say checkout counter, self check counter, right? So self checkout counter is a subclass of server. Everywhere where server is used, to let's say get a customer from the queue, etc., you can replace it with self checkout counter. Your self checkout counter behave like is a server, right? So I can do this. Okay. Or you can say that computable future is actually a future, right? Because everywhere in Java code where future is used, you can replace it with a completable future.
Your screen, I think.
Oh, sorry. There we go. Okay, so S is a subtype of T, self-check is a subtype of server, computable future is a subtype of future. So anywhere future is used, you can substitute with computable future. Okay. I'm going to use a more accessible example. Integer is a subtype of num. Right? Easier to think in terms of numbers. Right? Integer is a subtype of num. Now, when you have subtype like this, what can you do? Right? So if I have a variable t, right, I can actually do new s. Okay? Because s is a subtype now. S is a more specific, I can assign it to a more general one. Right? So I can say number n equals to integer, or server s equals to subject counter. Right? All this is possible. Right? But if I have list of t, right? If I have a list of t, right? I cannot say this list of t is a new array list of s. This is not allowed in Java. Okay? So this means that list of s, right, and list of t, list of s is not a subtype of list of t. And list of s is not a subtype of list of t. Not only that, list of t is not a subtype of list of s. So list of t and list of s has no subtype supertype relationship whatsoever. Okay? So this is what we call invariant. Invariant. One is not a generic of one is not of subtype of the other, and not the other way. Now let's see something that is covariant. Covariant means that if S is a subtype of T, then something S is a subtype of something T. What is this something? So it depends on what you want to look at. So for example, an array of S is a subtype of array of T. So this is a covariant relationship. Right? Array of S is a subtype of array of T. So what does it mean? So you have array of T, right? A, you can actually assign it to array of S. Okay, so this is covariant. So take another example. So if S is a subtype of T, right? And you have a function that returns S. A function that returns S, this is a subtype of a function that returns f function fx that returns S as a subtype function that returns T. Now you go back to the definition of subtype, right? Subtype means that anywhere this is used, you can replace it with another function. Okay? So let's say that I have a parent class called A, has the method T of F, right? I have a subclass B that extends A, right? I can actually override with the method F in my parent class with the function with the same name but return the more specific type. And we actually seen this in one of the recitations. Because if you think about it, anywhere you have a function f that returns t, I can substitute a function f that returns f, because s is a t now. So anywhere you have expect t, you put in substituting s, it still works. So this is covariance. Now what about wildcards? So this is example 1, example 2. Now example 3 is that in your S, which is a subtype of T, right? So list of S is a subtype of list of question mark extends T. Right? So just now we said now S and T no relationship, right? Now in order to be able to make our code more general, Java introduces these wildcards to bounds, so that now you can write code that takes in list of T or list of subclasses of T and so on. Right? So this is done by using wildcard extents. So list of S is a subtype of list of question mark extends T. So this is covariant. Final one is contravariant. So contravariant says that if S is a subtype of T, then something something of T is a subtype of something something of S. So this is the reverse, contra. This is the reverse. Okay? So there are two examples. One is in terms of our list or wildcards again. So if S is a subclass of T, then list of T is a subtype of list of question mark super S. Okay, so this is the reverse. Right? So any place that expects question mark super S, you can take in list of T. Now the other example is again in terms of function. So if your f which is a subtype of T, then a function that takes in T, right, is a subtype of a function that takes in F. Okay. Now you think about this. So you have a function. You have a function that takes in some S. Right? Let's say a function that takes in is this correct? Let me think first. You have a function that takes in integer. Anywhere you have a function that takes in integer. Yes, anywhere that you have a function that takes in integer, I can substitute this function with a function that takes in something more general. Let's say something that takes in object. And your code that passes integer will still work. Why? Because any integer is an object, right? Any integer is an object. So I can pass in integer to this new function f prime here. I substitute f with all f prime. The original code would still work. So this is the contravariant part, right? That. So I gave 2 examples of contravariant, 3 examples of covariant, and then this explains why it's invariant. Generic is invariant. Okay. Do you have anything more to ask about this? Okay, I hope I answered this question. Let's see, new question. Okay, I go to the one with one vote first. So this one answered. Will the tracing of water, okay, I won't answer question about what will be tested in the final. Obviously, I can't answer this question. Why do you use blah 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 in the function with better practice that we are time waiting for compilation as well simply using t instead works. Okay. So this is the question. Alright. So this will continue from our discussion earlier. Now remember, if you have S subtype of T, then list of S is a subtype of list of question mark extends T. And list of T is a subtype of list of question mark. Okay. Now let's suppose that you write a function, let me call it foo, and foo only takes in a list t. Okay. Alright, just taking a list of t. Now, if you have a list of t, right, I can pass in my list of t. List of t. So this one, okay, right? But if I have a list of s, right? List of s meaning the type is list s. List of s. If I have a list of s like this, can I pass it into foo? You can't. Java will not allow you to pass list of s into a function that expects list of t. Now, you want to pass in list of s into a list of t, you have to create a list of t. You have to create a list of t, then you take your s objects and then you put your s object into your list of t. Now this is allowed because s is a t, right? S is a subtype of t, so you can put s star into the t star. Right, then you pass in this list of t into your foo. Right? So you cannot pass in list of s. So let's take a more familiar example. Let's say you have let's say you're a supplier, right? So you have a function that takes in a supplier of, let's say, what do you call it? Number. Right? So this is a function that takes a supplier of number. Right? And then somewhere you have a supplier of integer. Right? Integer is a subclass of number, subtype of number. You have a supplier integer. Now you cannot pass in s into this function, even though integer is a number. Right? Integer is a number. You have a supplier that produces an integer, which is a number. You cannot pass in supplier integer into this function bar, because this function bar die must accept supplier of number only. Okay. Of course, yeah, you can then, okay, now I change this to supplier of number. There you go. Now, if you control everything, that's fine. You can simplify everything and make sure it works. but then you don't have control of every line of code that you write, right? Sometimes somebody will return you a supplier of integer. Then how do you convert this supplier integer to number? You have to do some or create new supplier, etc. Right? So very legit. So how do we deal with this? Right? So to deal with this, we have to use the extend and super. Now, using it is not hard. You just have to understand the principles behind extend and super. So first thing that you have to understand is this relationship, right? List of anything extends T is a superclass of list of S, and is a supertype of list of S. It is a supertype of list of T, right? It is a supertype of anything that extends T, right? You can think of wildcard extends T is T or anything that extends T, right? So it's not hard to think about this. So now you want to write, what you want to write is this list of question mark extends T is. If you write your function full like this, right, then you can take in list of T, no problem. You can put in list of S, no problem. Because list of S is a subtype of list of question mark super T, right? And remember, when you take in some, you have an argument, you can pass in that argument type or anything that is that subtype of that, right? So you can take in full list of T and pass in full list of S. Okay, huh? So to continue on, suppose you have going back to the restrictive version of this again. So you have list of T. Suppose we have this thing. I cannot pass in list of object. List of object meaning something with this type of list, triangular bracket object. Right? This thing I cannot pass it in, even though T is an object. So if I have a list of object, I put only T's inside. I cannot pass in this list of object into my function full. Okay? So in order to be able to take in list of object, right, I have to write my method like this, which is list of question mark super T. I have to write like this. Now, since question mark super T means T or anything that's superclass of T, right, which includes object. If I write it like this, then I can take in list of T, no problem. I can take in list of object, no problem. Right? Why? Because list of T is a subtype of list of super S, right? List of object is also a subtype of list of question mark super S. Right? Because S is also a subtype of object. Right? So this relationship holds. Okay. So now you see that simply using this works, but it's very restrictive. So you have seen this in your trace class in your lab 6, I believe. They want you to write a trace, and then we give you a trace of number. This trace of number is supposed to take in a function that takes in an object and return something else. Right? And if you only use a function that takes in t and returns t, it's not going to work. Right? Because in that case, your function can only take in number and return number. It cannot take in a function or object. Okay? So using this is simple and it works, but your code is not general enough. So that's why in a lot of the Java API, you see a lot of question mark extends t and question mark super t. Okay? But I have just explained to you from the point of view of the types. Right? So the type matches and you can pass things in. Right? But what do you do inside the methods? Okay? So this will determine whether you use list of t, list of question mark extend t, or list of question mark super t. Okay? So let's look at list of question mark extends t first. Right? List of question mark extends t. Now I take in my list. Can I add s to it? Can I add t to it? Which one will Java allow? Or maybe it doesn't allow both. Now, you think about this. So, what are some possible type of lists that foo can receive? Well, foo can receive list of t. He can receive list of s. If I have r, which is also a subtype of t, you can also receive list of r. If you have you have t, which is subtype of r, subtype of t, you can take in list of t. So you can take in many different types of lists, as long as it is list of something that extends from t. Okay? So what's the safest thing? Now, should Java allow you to add s into the list? Shouldn't. Why? Because there's no guarantee that this list can accept an s. Correct? What if I call my foo? What if I call my foo, right, with a new list of t? This is still valid, because p is a subtype of t. So again, I create a new list of t and pass it in, and then inside you want to put s inside. S has nothing to do with t. Okay? If it is too abstract, you think of it as t as object. T as object, p is a string, s is a number. I can create a list of string, pass it in, and then you try to add number into this list of string. Right. Cannot. So the safest thing Java allows you to do is to only add t inside. T is safe because whatever list that you pass in must be a subset of, must be a subclass of t. Is that right? Actually no, because here I pass you a list of t, right? Now you give me something of t. T is a superclass, right? Since t is a superclass, t can actually point to anything. So you cannot take in t as well. So actually you can't do much. You can't add things inside this list. You can't add things inside this list. So what is it good for? Or if you can't add things, but you can extract things out. Right? You can